Now see a new concept, that is a total internal reflection of light. So, we have done the reflection of light and refraction of light. Now, we will do here the total internal reflection of light. Now, see here in this case we take the light rays travel from denser to rarer medium. See the example here or illustration of this. Suppose this is the interface and this side is here denser medium. Now, in this denser medium, suppose I take first example here, in this case there is this point here and the light ray is going in this manner. This is angle of incidence I. Some part of the light is refracted and some part is reflected. If I take another example here in this case and angle of incidence is increased slightly here, then again the same thing happens. Angle of refraction is like that, as I increase angle of incidence, angle of refraction has increased and now some part is reflected and some part is reflected and some part is refracted. Let us go for the another example. If I take another example in this case here, suppose angle of incidence is like that, here this is angle of incidence, refracted ray is going like this. So, angle of refraction is 90 degree. So, when light travels from denser to rarer medium and angle of incidence we keeps on increasing, we find that at the certain angle of incidence, angle of refraction is 90 degree. This angle of incidence is known as critical angle. So, in this case we can say here I is equal to C. So, what is critical angle is actually here? Critical angle is the angle of incidence for which the angle of refraction is 90 degree when light goes from denser to rarer medium. Now, if you increase angle of incidence further, it means more than the critical angle, you will find, if you increase further this one, you will find the ray will, if you are taking like this, the ray will be coming back into the same medium. So, now if angle of incidence is more than the critical angle, this light is completely reflected and coming back into the denser medium. This phenomenon is known as total internal reflection of light. So, here the light is going from denser to rarer and it is coming back into the same medium. Now, we can solve here, we can see here the what are the conditions for this total internal reflection. First one, light rays should travel from denser to rarer medium, and second important condition is here angle of incidence should be greater than angle of critical angle. Now, we can also write here refractive index of the water or this medium we can take mu is equal to sin r upon sin I, and we can write when the angle of, when you can write I is equal to C. So, we can write mu is equal to sin 90 divided by sin C, and sin 90 is 1. So, we can write 1 upon sin C. So, this is the relation between refractive index and critical angle.